All right, this time we're going to look still at the same thing. We have a boat and a river, but this time we want to cross to a point directly north of where we start. So if we draw it, there are the banks of the river, and what we want to do is cross from here to a point directly north of where we start. We want to go straight across, and that's easy if it's still water, but what we have right here is a 5 meter per second current. So if we start off pointing straight across, we're going to drift downriver, just like we did before. So what we need to do is take our 10 meters per second and point it into the current just a little bit. What that's going to do is fight off that current so we can go straight across. And our goal is to put 10 meters per second this way and have that angle be just right so that the 5 meters per second of the current pushes me back towards that straight line and my resultant velocity points straight north. If that's the case, then we're just going to follow that line right across. So, looking at it, to find this angle, I'll redraw that triangle. 10 meters per second this way, 5 meters per second, that pushes us back this way, and resultant that points straight up. We want this angle. Well, 10 is my hypotenuse, 5 is my opposite side, and if I want that angle with those two things, I'm going to use the sine function. Sine of that angle is equal to 5 over 10. So that angle comes out to be 30 degrees. So if we're going to cross that stream, we need to point ourselves 30 degrees into it in order to make it across in a straight line. So that's 30 degrees, and as we have it drawn, it is west of north. Now, that's going to affect how long it takes this guy to cross. So let's look at how long it takes to cross. Now we're still talking about a 100-meter wide river. And if we're looking at how long it takes to cross, well, just like before, that's a y direction question. So we have to explore what we have in the y direction. We know that our delta y is 100 meters. And in order to get our time, we need that delta y divided by the velocity in the y. Well, we weren't really given that. So let's look at our triangle here. This 10 meters per second is not in the y direction. It's 10 meters per second directed at 30 degrees west of north. Our velocity in the y is right here. It's the resultant velocity that we had from doing all that, and it's pointing straight north. That's the one we're after. So we need to find that velocity in the y. So looking at our triangle, if our hypotenuse is 10 and our opposite side is 5, then the velocity of the y is going to be 10 squared minus 5 squared, because that's the hypotenuse. We took Pythagorean theorem and rearranged it a little bit. So that velocity in the y direction comes out to be 8.66 meters per second, right to the north. So we're going to take that and use it here and say that our time is 100 meters divided by 8.66 meters per second. So that time comes out to be 11.5 meters per second. No, sorry, 11.5 seconds. So, if you would have just pointed straight across, it would have taken him 10 seconds, and he would have floated 50 meters downstream. As it is now, we're pointing into the current 30 degrees, going straight across, and it's taking us 1.5 seconds longer.